to prove sin theta minus cos theta plus 1 over sin theta plus cos theta minus 1 equal to 1 over sec theta minus tan theta. So let me start from the LHS. We have terms in terms of sine and cos. So we need to prove in terms of sec and tan theta. So let's first try to convert the terms sine and cos in terms of sec and tan theta. It's easy because we know that if we divide by cos, sine by cos, we get tan, and by 1 by cos, we get sec and theta. So the first step would be to divide the numerator and denominator by cos theta to convert it into sec and theta and tan theta. So sine theta over cos theta minus cos theta over cos theta plus 1 over cos theta divided by sine theta by cos theta plus cos theta over cos theta minus 1 over cos theta. So the next step would be the sine theta over cos theta is nothing but tan theta, and then over cos becomes 1, and 1 over cos is nothing but secant theta. And then sine over cos again as tan theta, and then cos over cos is 1 minus 1 over cos is secant theta. Whenever you have three terms and when you're stuck over there, there is this trick of converting the three terms into two terms, and then you can proceed further. So let's convert these three terms as two terms. Okay, so the first two terms I'll club together and make it look like a single term, and I have another term here. So I'll consider this as A and this as B and multiply by conjugates. So when you multiply by conjugates, you get tan theta. You just change a sign in between. So tan theta plus 1 plus secant theta. Same thing, multiply and divide by conjugates. So tan theta plus 1 plus secant theta. This is a minus b and this is a plus b. So you get a square minus b square in the next step. So this becomes, so here I will be multiplying all these three terms with the three terms over here. So we'll do that in the next step. First, let me write it properly. The numerator becomes tan theta minus 1 plus secant theta times tan theta. This, I'm removing the parenthesis around the first two terms, so this becomes tan theta plus 1 plus secant theta over a squared minus b squared formula. So a is 1 plus tan theta, so tan theta plus 1 the whole square minus b squared is secant theta, so secant squared theta. So let me expand the numerator now. So this becomes let me start from here. So since it is big, so first let me multiply this tan with all the terms over here. So tan theta times tan theta becomes tan square theta. Tan theta plus 1 becomes tan theta. Tan theta times secant theta becomes tan theta secant theta. Secant theta. Now I'm taking the next term minus 1 and multiplying with all the terms in the second bracket or parenthesis. Okay, so minus 1 times tan theta is minus tan theta, minus 1 into plus 1 is minus 1, minus 1 into secant theta is minus secant theta. Minus tan theta minus sec 1 and minus secant theta. Now I am taking secant theta and multiplying with all the terms in the second parenthesis. So secant theta and tan theta multiplied by tan theta gives me secant theta tan theta, and 1 into secant theta is secant theta, and secant theta times secant theta becomes secant square theta. And let me expand the denominator as well. So the denominator becomes a plus b the whole square formula. So tan square theta plus 1 plus 2 tan theta minus secant square theta. Okay. Here this plus tan theta and minus tan theta gets cancelled, and minus secant theta and plus tan theta plus secant theta gets cancelled, and what is left out, we have tan square theta in the numerator, and you have a tan secant theta here, and plus tan secant theta, and this plus tan secant theta becomes 2 secant theta tan theta. And what is left out, you have a minus 1 here, minus 1, and then 1 secant square theta over, let me write this properly, this is tan theta. Okay, now in the denominator you can see you have a tan square theta plus 1. So we apply the formula here, 1 plus tan square theta equal to secant square theta. So this becomes secant square theta, 1 plus tan square theta becomes secant square theta plus 2 tan theta minus secant square theta. So this and this gets cancelled. And you have secant square theta. What is tan square theta here? Tan square theta is nothing but secant square theta minus 1. So this secant square theta and this minus 1 becomes tan square theta. So tan square theta, and you have 2 secant theta tan theta, and then you have secant square theta minus 1 becomes tan square theta here over 2 tan theta. So this is 2 tan square theta plus 2 secant theta tan theta over 2 tan theta. I am taking the common 2 tan theta outside, so this becomes 2 tan theta times tan theta plus secant theta over 2 tan theta. This and this gets cancelled. Now I want my RHS is 1. I have to prove it as 1 over. They're asking me to prove as 1 over secant theta minus tan theta, right? So I am left. What do we get here? Tan theta plus secant theta. So the best way to get the denominator as secant theta. So to get the RHS, I'm multiplying and dividing it by secant theta minus tan theta. Multiply and divide by secant theta minus tan theta. Okay, so again multiply these two, tan theta secant theta, tan theta multiplied with the multiply these two binomials, tan theta and secant theta becomes tan secant theta minus tan theta into tan theta becomes minus tan square theta plus secant theta into secant theta becomes secant square theta and minus tan theta secant theta here. So this tan theta secant theta gets cancelled, and you have secant theta minus tan theta in the denominator. And again you apply the formula secant squared theta minus secant squared theta minus tan squared theta is nothing but 1 from the formula, right? So we get a 1 here, and your answer is 1 over secant theta minus tan theta. That's it. Thank you.